Okay, so here we go. 5.6, we're going to talk about something called the Rational Zero Theorem. And it's a little bit weird at first, but once we get the hang of it, it's actually pretty easy. I'm going to kind of come around the back door here with it, is we're going to call the constant P. And P, we're going to list the factors of the constant. And a constant, remember, is a number without a variable. Q will be the factors of the leading coefficient. And the rational zero theorem says this: P divided by Q are the possible rational zeros. Now that's kind of a abstract explanation. P divided by Q are possible rational zeros. But let's pick this apart a moment. What does the word rational mean?
Real numbers?
It's a whole number.
Well, they include whole numbers, but
it's not terminating. Well, it terminates.
it can be a decimal that terminates or repeats. But there's a real simple way to describe a rational number.
Anything that's not irrational.
Okay, it's definitely something that's not irrational. That's definitely true. Okay, but I don't know that that's going to help somebody. It can be written as a fraction. A rational number is a number that can be written as a fraction. So 5 is rational because I can write it as 5 over 1. But so is 1/4. But you're terminating, like 1.5 is 3 halves. I know how to convert all terminating to fractions. But it's anything that can be written as a fraction. And then what's a zero?
X.
It's an x-intercept or a solution, right? So the rational zero theorem gives us a list of possible rational zeros. So if you remember in the previous lesson, we were given a zero and we did synthetic division. And I mentioned we're going to get to a spot where we don't need them to give us any. And we can use this rational zero theorem. Well, do you remember in the Bible how it says the first shall be last and the last shall be first? Here, I use that to help me remember this, is the constant is the last in the list, but we're going to put it first, okay? So P, and give me a couple of examples, at least 2, before you start asking any questions. I need you to sort of just watch and follow the patterns, and then we'll clarify it. If P is 12, the possible factors are plus or minus 1, and leave a space here, or it would be times 12. But see, I could have 1 times 12 or negative 1 times negative 12, right? And then I could do 2 times a 6, but I need the plus or minus. And then I could do plus or minus 3 times plus or minus 4. Okay, because you don't know what the signs are to multiply them together. And then Q, the only possible factors are plus or minus 1. It could have been 1 times 1 or negative 1 times negative 1. Okay, so the rational zero theorem says the possibilities are all the P's divided by all the Q's in every combination. Well, if I take 1 over 1, that's still the 1. If I take 2 over 1, it's still 2. 3 over 1 is still 3. 4 over 1 is still 4. 6 over 1, 6 over 12. But you do need the plus or minus symbols because we don't know which they could be. Now, in the first few examples, it just says list the possible rational zeros. It doesn't say what are they. It just says what are the possibilities. So the rational theorem gives us a new tool that gives us some options. All right, so let's do it again. P is the factors of the constant. So the factors of 10 are going to be plus or minus 1, plus or minus 2, plus or minus 5, plus or minus 10. In Q, I have 4. How can you multiply two numbers to get a 4? 2 times 2 and 1 times 4. So it's plus or minus 1, plus or minus 2, plus or minus 4. We don't need to write the 2 twice. That takes care of it. Now, when I do P divided by Q, you actually have 2 options. You can, and the way I do it is I take every P value and I divide by the first Q, and then I take all the P's divided by the second Q, and all the P's divided by the third Q. That's how I see it. Some students will do this. They'll take the 1 divided by 1, 1 divided by 2, 1 divided by 4. And then they take 2 divided by 1, 2 divided by 2, 2 divided by 4. 5 divided by 1, 5 divided by 2. However you see it, it doesn't matter. So I'm going to take everything divided by 1, which just gives the original list for P. And then I'm going to take everything divided by the 2. So now that's 1 divided by 2 is 1/2. But what do you know about 2 divided by 2? It's 1. We already listed it, right? You don't list it again. And then I have 5 divided by 2. But what's 10 divided by 2? 5. We already have that. Now I'm going to divide by the 4. So I get 1/4. What's 2 divided by 4? It's 1/2. We already listed 1/2. And then I've got 5/4. And then what's 10/4? 5/2. We already have it. So here's the list. Alright, is this starting to make sense? How we're going to use it, you'll have to wait a moment. Alright, so here we go. Let's try it on the third one. P, remember, the first shall be last and the last shall be first. So you're always going to start with the constant. So what are you going to put down for P?
Plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 6.
Good job. And then what do you know about Q?
It's just plus or minus 1.
Okay, and once you get the hang of this, if Q is 1, I end up skipping a step because if you divide by a 1, it's just the row of P, isn't it? Okay? And again, the only thing I'm being asked to do is to list the possibilities. And that really is truly amazing if you think about it, because there's infinitely many rational numbers, and we can fine-tune it to just 8 possibilities to try. Okay? All right, try example 4 on your own. Try and go the whole way through. Then do you see all the other ones you have? So you just had the P plus or minus 1/2. Everybody got it? Okay, now we're going to see how can we use this. In example 5, it actually says find all the real zeros. Find all the real zeros. Well, because Q is 1, I'm going to skip a step here. P is plus or minus 1, plus or minus 2, plus or minus 4, plus or minus 5, plus or minus 10, plus or minus 20. But because Q is 1, do you see I can list it and make it P over Q? That's the shortcut I can use. Now here's the interesting thing. Take out your graphing calculators. No, we're not going to graph it. But I want you to go to your Y screen and we're going to enter the function. And do you guys know that there's an X cubed button? If you press math number 3, that'll cube for you. Okay. Now, our possibilities were plus or minus 1, plus or minus 2, plus or minus 4, plus or minus 5, plus or minus 10, plus or minus 20. That's a lot to scroll up and down your screen. So let me show you an option. You can press second and window, and I want you to go down to independent, and I want you to arrow it onto the ask and press enter. Now yours will end up being blank then if you have a newer calculator, but because I've already been doing this, mine has stuff in it. But here's what we're going to do. We're going to type in 1, -1, and we're just going to start entering the values. And do you see on our second try we got a 0? So we're going to stop here a moment, okay? I know that x equals -1 is a 0. Now we're going to try to make a connection to what we did in the previous lesson. Do you remember how we did synthetic division? And if we knew a 0, we could factor it and divide it down to a quadratic. And then we know how to factor quadratics. So watch. I'm going to put -1 in the box. And what I'm doing is I'm dividing it down really by x plus 1 to create a quadratic equation. Okay? So we bring down the 1. And we ought to get a remainder of 0. Remember the remainder theorem. So this represents x squared minus 9x plus 20. It factors nice and easily. Now don't get lost in your work, okay? We're doing a lot of different things here. But it says find all the real zeros. So let's kind of organize it in one location. And you're going to put a box around those 3 answers. So let me go over this again, what we did. It said find all the real zeros. Those are the x-intercepts. So we did the rational zero theorem to come up with one of them, divided to make it an x squared, and factored the quadratic to get the other 2. Does that make sense, what we did? All right, we're going to do another one. All right, example 6 says find all the real zeros. Okay, so P would be plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 6, plus or minus 9, plus or minus 18. Now Q is 1, so we can just make that our P over Q. So this will definitely be on the calculator part of your quiz Friday. So let's go to the graphing calculator to our Y screen, and let's enter this one. I get x cubed minus 4x squared minus 15x plus 18. Now we're on the ask feature, so the nice thing is our 1 and -1 are up there, right? And look, 1 is already a 0. So x equals 1 is a 0, so I can divide this down to a quadratic. Do you guys understand that if this were x to the 4th, I couldn't stop with one of them because I can't factor an x cubed necessarily. So I'd have to find 2 of them and then try to divide. All right, so I have 3 answers, -3, 1, and 6. Please be careful on the quiz Friday to read your problems carefully. If it says find the zeros, you need to find the solutions. But in 1 through 4, it said list the possible rational zeros. You're not finding them, you're just listing what are the possibilities. Yeah, Jaslyn?
Can you go over the calculator part?
Yes, absolutely. Okay, so when you're entering it, then you're going to start entering those possibilities. So if I do that, if I get y is 0, that's a 0.
Yeah, how did you get to that whole
Oh, right here, you do second graph.
second graph? Okay.
Second graph. and then you just start punching in your numbers.
Oh, okay.
Okay, now did you go to your y equals to put the function in?
Mm-hmm.
Okay. Alright, now I want you guys to try example 7 on your own. I did not assign additional quadratic worksheet in first period, so I'm not going to assign that. Okay, but keep it because we'll keep going tomorrow. Oh, remind me about Piota.
Yes, it's a fun Christmas carol.
Mm-mm. Alright, did you guys get negative 1, 2, and 7 to work?
Yes.
Okay, so we're getting the hang of it. Alright, now, example 8 is pretty tricky, okay? Because here's the deal, it doesn't work out as nicely because Q is a 10. So P is plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 4, plus or minus 6, plus or minus 12. And Q is plus or minus 1, plus or minus 2, plus or minus 5, plus or minus 10. Okay, so I can do the list for P because that would be over 1. And then I'm going to divide by 2. Well, 1 divided by 2 is 1/2. 2 over 2 is 1, and I already have that. Then I would need 3/2. Well, 4 over 2 I have, 6 over 2 I have, and 12 over 2 I have. Now I'm going to divide by 5. So it's 1/5, 2/5, 3/5, 4/5, 6/5, and 12/5. Alright, then we're going to divide by 10. 1/10. Now 2/10 is 1/5, and I have that. I would need 3/10. 4/10 is 2/5, I have that. 6/10 is 3/5, we have that, and 12/10 is 6/5. Okay, so this one's a doozy to do. And here's the other problem. I can't just find one answer because that'll take me to an x cubed and I'm stuck. So I need 2 answers. Okay, I need 2 of these. So let's go to the calculator and let's enter this one. 10x to the 4th minus 11x cubed minus 42x squared plus 7x plus 12. Oh gosh, you guys, why didn't you catch me? Oh man, I gotta do that again. 10x to the 4th. That was all in my exponent. I hate it when that happens. Okay, now on this one, so 1 doesn't work, negative 1 doesn't work. Let's try 2, negative 2, 3, negative 3. These are not working. 4, negative 4, 6, negative 6, 12, negative 12. Now you guys, once you get to the bottom, it doesn't keep moving down. So you can just type them right here, or you can scroll back up to the top and go down again. Okay, so now I'm ready to do 1/2. So you just do 1 divided by 2. Here's negative 1 divided by 2. Bingo, we have one winner. Okay, so just remember that one. Now let's do 3 divided by 2. Nope. Negative 3 divided by 2. Nope. 1/5. Negative 1/5. 2/5. So this really is a test of patience and perseverance. And 3/5. We finally got a winner. Okay, so we had x was negative 1/2 and x is 3/5. Now, up to this point, when we were doing that factor theorem, like if x was 2, we knew a factor was x minus 2. Well, when it's a fraction, it doesn't work that nicely. So what you have to do when it's a fraction is you're going to multiply both sides of this by the denominator. So I get 2x equals negative 1. And so the factor is actually 2x plus 1. And then over here, if I multiply by the denominator, I get 5x equals 3. So 5x minus 3 equals 0. So what I'm going to do is I'm going to multiply this out, okay? I'm going to take 2x plus 1 times 5x minus 3, and I get 10x squared minus 6x plus 5x is minus x minus 3. And then watch what I'm going to do. If I take my 4th power divided by a 2nd power, that's going to leave me with a quadratic, won't it? I can't do synthetic division because it's not divided by x minus a number. I have to go back to long division. And so here's another good location as to why you would need long division. So again, let me restate it. We're taking this x to the 4th polynomial divided by x squared because it's going to leave me with an x squared. And I can solve any x squared, any quadratic. Alright, so I need to multiply by x squared, so I get 10x to the 4th minus x cubed minus 3x squared. I'm going to take the opposite and add, so I get negative 10x cubed minus 39x squared, and bring down the other two terms. Then I need to multiply by a negative x. Then I'll take the opposite and add. So I need what? A minus 4. So I'm trying to solve x squared minus x minus 4 equals 0. Well, it doesn't take a whole lot of effort to figure out that that doesn't factor. So we're going to use quadratic formula, and we can use our program here. So my solutions are negative 1/2, 3/5, 2.56, and negative 1.56. Notice it was x to the 4th, and so I have 4 answers.